Okay, so in the last lesson, you guys came across, or we came across this number right here, and I said I was going to show you how to simplify that or give you a refresher course on real quick on how to simplify that. So that's what we're going to do. Now keep in mind there's actually two different methods for simplifying radicals. I'm going to show you just one. If it doesn't work, let me know, email me, I'll show you the other way, which is a little bit more cumbersome, but it works. In order to quickly simplify radicals, you need to know what the perfect squares are, and you also have to be really quick with your division facts from elementary school. Perfect squares are numbers. When you square them, you get what you get is called a perfect square. So if you square 1, you get 1. That's a perfect square. If you square 2, I should probably go like this. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, and so on. Anyways, the result of squaring these are called perfect squares. And when you're simplifying radicals, if you know those quickly, it'll make your life a lot easier. Now, this one doesn't really apply to simplifying radicals, so we're going to always ignore the 1. And let's start with some easier examples. So, square root of 12. What you have to do is figure out which perfect square goes into 12. The biggest one, you have to find the biggest perfect square that goes into 12, which is obviously 4. So the square root of 12 is equal to the square root of 4 times the square root of 3. I'm going to pause for a second so you can digest that. Should make perfect sense. If you're not sure, you can always just check. If I take the square root of 12, press enter, you get that decimal. So I'm saying that the square root of 4 times the square root of 3 is the same because I used the equal sign. So when I press enter, it better give me the exact same decimal, and it does, identical. So, and then instead of going across, I'm going to actually show my work going down at this point, because it makes more sense. The square root of 4 is exactly 2. The square root of 3 is, we don't know, so you're going to leave it like that. This is a perfectly acceptable way to write that expression, but most of the time you're not going to see that dot. So the way you say it is 2 times the square root of 3. And then if you don't see the dot in between, it still means the same thing, but I say 2 radical 3. A lot of teachers say 2 root 3. But if you want to be technically correct, and if you're on the math team and you're asked a question how to say this, the only proper response for that question is 2 times the square root of 3. Okay, another example. Radical 40. What's the biggest perfect square? Does 4 go into it? Yes. Does 9? No. 16? No. 25? No. 36? No. Obviously 49 doesn't go into 40. So square root of 4 times square root of 10. And oops, I'm going to go down instead of across. You can go across if you want. Save room. Square root of 4 is 2. Square root of 10 is 3 point something. We don't know, so we're going to leave it as a radical expression. Voila. Next example. So we're going to go back in a second to the previous lesson and simplify our answers some more using this expression, not that expression. And square root of 75 What's the biggest perfect square that goes into 45? 4 doesn't work at all. 9 no. 16 no. 25. Yes, 25 times 3. And then the square root of 25 is 5. So 5 radical 3 is the answer to that problem right there. And a couple more. 18. The smaller the number, the easier it is for you. And vice versa. The larger the number, the harder it's going to be. Biggest perfect square that goes into 18 is 9. So you're going to get 9 times the square root of 9 times the square root of 2 equals square root of 18. Square root of 9, I'm going to go across this time. Hopefully that doesn't mess you up. Square root of 9 is 3. Square root of 2 is 1.414, but you don't know that, so you're going to leave it like that. 3 radical 2. 3 root 2. And then, last example. We see this all the time in school. So, square root of 80. What's the biggest perfect square that goes into it? 4 does go into 80. Everybody knows that. Dun, dun, dun. So they go, 4 times 20. Today is 420. Interesting coincidence. Square root of 4 is 2. Square root of 20 is we don't know. So you leave it as a radical. And is it true that this equals this? Yes, it's true. But it's not simplified. And just like a fraction, like if we gave you this fraction and we said simplify it, and you tell us 8/10, you kind of simplified it, but the word simplify means to simplify completely, to reduce completely. So this is the only correct answer. This is kind of like partial credit. You kind of simplified it, you kind of reduced it, so you kind of know what you're doing. Same thing here. The goal is to simplify this, and you kind of do. This is kind of correct. But if you remember at the beginning, I said this method only works if you find the biggest perfect square that goes into 80, and it's not 4. 9 doesn't even go into 80, 16 does not. Yes, it does. 16 does go into 80. It goes into 80 5 times. Square root of 16 times the square root of 5. Let me double check. Don't believe me? Just watch. That's Bruno Mars quote, by the way. So, square root of 80 equals that decimal, and I'm saying that it also is equal to square root of 16 times square root of 5. So, square root of 16 times the square root of 5 should give me the exact same decimal. So yes, this and this are in fact equal to each other. So the difference is I now have found the biggest perfect square that goes into 80, not a perfect square. Dun, dun, dun. Square root of 16 is 4, and you don't know the square root of 5, it's like 2 point something. So the answer to this question is 4 radical 5. 2 radical 20 is kind of correct. So it'd be like half credit for that answer. Okay, and then what else? Oh, something called rationalizing a denominator. Sorry, this is long video. Rationalizing denominators. Okay, and I am gonna go with this. So let's say you're doing sine, cosine, tangent, and you end up with this as your answer. Like I said in previous lesson or previous video, some teachers, some professors, some books think that this is perfectly acceptable. If your teacher doesn't, here's what you do to rationalize the denominator. Whatever radicals on the bottom, you're going to multiply the top and the bottom by that number, and you get on the top 2 times the square root of 6. On the bottom, square root of 6 times the square root of 6. I don't show all the work here, but is the square root of 36. And the square root of 36 is exactly 6. And it's not done yet. So, real number, if you can reduce them. I shouldn't say real number. Non-radical number, 2 6. So if you ignore the radical part of it, just like in elementary school, if your answer ended up being 2 6, we would want you to reduce that. So it's going to become a 1 and a 3. Or just, voila. So that, believe it or not, is equal to that. Again, you can check on a calculator to see if you actually did it correctly. So 2 over the square root of 6 equals 0.8164 blah blah blah. And I'm saying after all this work that this is the same thing. Well, we're about to find out. Square root of 3 divided by 6 equals, yeah, what did I do wrong? Ah! 2 6 equals 1 6. That's funny. Let's whoops, guys. Sorry about that. Now let's try it. So square root of 3 over 3. Making videos is not as easy as you would think. Talking to a stinking whatever this thing is, not as easy as you would think. So 0.57 da 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 da, and then 2 divided by the square root of 6 should have given me the same thing. Oh my goodness. 2 divided by the square root of 6. Why is it not the same? Let me go back and check my work. So multiply top to bottom. Looks good. 2 times square root of 6, yes. Radical 6 times radical 6 is radical 36. That's fine, that's fine. 2 6 is 1/3. Ah! Oh my gosh. This is horrible. 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 I could just make a new video, but not gonna happen. Way too time consuming. Alright, let's do this again properly. 2 times the square root of 6 over 6. So the only thing, oh my goodness, the only thing that's getting reduced is that 2 and that 6 to a 1 and 3. So you get a 1 radical 6 over 3, or just simply radical 6 over 3. Oh my goodness, I'm super sorry. Now it's going to work. The square root of 6 over 3 equals, I'd like to say I'm 100% sure, but after what you just witnessed, I'm only like 80% sure it's correct. Oh, jeez. Well, if you wanted to see a not so great lesson on rationalizing denominators, there you go. Shoot. And then, so if we go back to this assignment, we know that that is equal to 2 times the square root of 10. So let me continue down here. So you have 2 over the square root of 40, and we know that this is equal to 2 times the square root of 10, and the 2's get reduced. Okay, and then you can't leave a radical on the bottom, and so you must, it's called rationalizing the denominator. So you're going to multiply the top and the bottom by the square root of 10. And what you end up getting is 1 times the square root of 10, which is just square root of 10. And that is the square root of 100, which is just 10. So this is the actual answer to this problem. At least I hope it is. So I'm a little bit scared to check. A little bit scared. But this is why you check. What you witnessed is exactly why you want to check. Because sometimes your brain just doesn't work. And now if I go to square root of 10 divided by 10, hopefully I get the same thing. Oh my gosh, I'm so scared. I'm so scared. Yes! I am victorious! Okay. So, hopefully that's a little quick lesson on rationalizing denominators. Oh my goodness. Not as easy as it seems, apparently. Well, I guess it depends on how awake you are. But about 16 minutes and like 2 minutes of that was nonsense. Sorry about that.